This video is being made to make you all understand a new method for evaluating the antifungal activity of certain volatile compounds. Before actually describing the method, I would like to take you all through the regularly employed antimicrobial procedures, antimicrobial activity screening procedures, which we usually do in any kind of microbiology laboratory. We usually use agar well diffusion method, where an well is digged in the agar and the compound is placed in this well, and the compound is supposed to diffuse through the agar and show its inhibitory activity. Other usually employed method is disc diffusion method. In this method, on the agar surface, which is preceded with inoculum, we use a paper disc on which the compound is impended. So these are usually used methods. Now the question is, can we use these common methods to test the antimicrobial activity of volatile compounds also? Why this question comes is, volatile compounds are special and testing their antimicrobial activity is not an easy task. The above methods, which I have discussed in the previous slides, are basically based on the diffusion of the compound in the solid agar medium. Whereas we all know that volatile compounds will not diffuse in the solid agar medium. Right. Volatile compounds, they exhibit differences in antimicrobial activity in liquid state and in volatile phase. I mean to tell you that the volatile compounds, when they are in liquid state, they behave differently, and when they move into volatile phase, their activity can be different. So we can't expect them to exhibit same kind of antimicrobial activity when they are present in liquid state as well in their volatile phase. So there should be a special technique are required to determine the antimicrobial activity of volatile compounds, especially when these compounds are in their volatile phase. With the above methods described in the previous slide, you can't predict the active component which is actually showing the antimicrobial activity whenever you are taking mixture of compounds. Means if your solution is having both volatile and non-volatile components in it, you can't predict whether the volatile compound is active against microbes, or is it the non-volatile compound present in the mixture that is responsible for exhibiting the actual antimicrobial activity. So the efficacy of volatile compound alone cannot be determined. We can't even predict the actual mechanism of how these volatile compounds can act on microbes. This also can't be studied. We know that certain volatile compounds are hydrophobic in nature, so their solubility in water is again a problem. So we need to go for solubilizing these compounds in certain organic solvents, where again the compounds may partition into organic solvents, which can lead to lowering of final concentrations. So we face all these hurdles, in fact, if we employ regular antimicrobial evaluation techniques, if we employ the same methods for evaluating the antimicrobial activity of volatile compounds too. So there is a requirement to design a new method to evaluate antimicrobial activity in case of volatile compounds. So with this motto, there were few latest methods which I found in the literature. One method was proposed in 2011 by Singh. Who was the author of that particular paper. So they developed a apparatus and a simple arrangement where they can evaluate the activity of volatile compounds only against vegetative forms of bacteria. So this method can't be employed for spores. This method can't be employed for fungal cultures too. And even in this method you can't evaluate how much is the minimum inhibitory concentration of the compound. Recently in 2021 there was another method proposed by Arbus et al. Where they have fitted a glass vial in the agar well, and inside this glass well the volatile compound was supposed to be filled, where this method can successfully prevent the direct contact of the volatile compound with that of the agar medium present. However, again this method has its own disadvantages of you can't predict the minimum inhibitory concentration. You can't employ this method in case of antifungal activity evaluation. So there are certain disadvantages. Also, another important disadvantage is that you are doing this method using a regular petri dish, where the space for the distribution of the volatile compound is again limited, so you can't actually predict the activity of the volatile compound, right? So in order to overcome all these problems which were there in the existing methods for evaluation of volatile compounds, there came a newer method, a novel method, which is known as conical flask paper cone hanging method. This method was designed especially to evaluate the antifungal activity of volatile compounds. So coming to the design of this apparatus is basically designed using a regular conical flask. This conical flask should be filled with about 30 ml of medium, 30 ml of growth medium, solid growth medium, and then you can find a thread hanging here, right? The thread actually comes from here, a thread to which a filter paper which was cut in the shape of a triangle or a cone shape is hanged here. In fact, this cone shaped filter paper is the one in which the volatile compound is impregnated. Certain volume of the volatile compound, may it be 5 microliter or may it be 10 microliter, has to be impregnated on this, has to be spotted, impregnated on this cone shaped filter paper, which is hanged with the help of a thread. And you need to maintain a distance of about 1 to 2 centimeters between the growth medium, the surface of the growth medium, and the paper which is hanging over here. And here is where a fungal disc is inoculated. And once the fungal disc is inoculated and paper is hanged inside the conical flask, you need to cover the top portion of this apparatus with a parafilm, so that covering with parafilm is going to prevent the escape of any amount of volatile compound from this apparatus, right? This apparatus can be incubated for 5 to 7 days, or it even can be incubated up to 10 to 15 days also. If the volatile compound concentration is enough to inhibit the organism's growth, here the fungal disc whatever we have inoculated cannot grow, which shows that the volatile compound present on this paper disc was actively acting against uh, the fungal growth. Especially in this method, because only the compound which is volatile will spread in this whole area available over here, and it will start inhibiting the activity of fungi. So we are sure that only the volatile component, even if you are impregnating a mixture of compounds, we are pretty sure that only the volatile component, that too in the volatile phase, is the one which is actually inhibiting the growth of the organism. So the main advantages of this method is you can actually calculate the amount of any volatile compound. For example, eugenol taken in my work, the amount required per centimeter cube of area can be determined by calculating the inner volume of the conical flask. The formula goes here. The minimum amount of volatile compound required to exhibit antifungal activity divided by volume occupied by the volatile compound is equal to the minimum inhibitory concentration of the volatile compound required per centimeter cube. So this method is helping us even to calculate how much amount of volatile compound per centimeter cube is required for successful inhibition of whatever the fungal culture we take, the test fungal culture. So here we need not to worry about solubility of the volatile compounds, because directly different concentrations, different amounts of volatile compounds, I mean different volumes of volatile compounds can be impregnated on the paper cone. The vapor inside the apparatus, I mean the conical flask, can also be analyzed by fitting it to a sophisticated GCMS kind of apparatus too. Finally, the question is talking all about this method. Is this method really validated, or is it really published in any journal? Yes. Yes, this method is. Yes, this method was recently published with the title of the paper, the first report on post-harvest management of black mold of onion by eugenol. Anyone interested to know more about this method, this technique, its procedure, how it is useful in determining various parameters of the volatile compound, one can really refer this paper. Yeah, this method is also, you can also measure the radial growth of the fungi, just like as we measure using when you inoculate in a petri dish. Similarly, you can also measure by turning top side bottom of your conical flask. One can also measure the radial growth of the fungi, and we can calculate various parameters, and you can compare various parameters too.